Hello, this is Mr. Huff, and let's go over this project. This is Principles of Engineering. We are going to do Launch and Learn. We're going to do projectile launching and analysis in this project. So this slide is going to be the introduction, and it talks about projectile launchers and kind of an overview of what this is going to be about. One of the things I want to point out here are the primary design goals. Your design needs to include an adjustable launch angle. It needs to be accurate and consistent, and you make the design mobile, and resources are limited to tools and supplies you have at home. This is a design brief. I will let you read through this. That's pretty straightforward. It's just basically saying you're going to design and construct and test a launcher. I do have some recommendations, though. I've done catapults and trebuchets and those sorts of things as projects in the past. I'm going to recommend that you begin your problem design with something like a ballista. And a ballista is basically a big crossbolt mounted on some sort of stand, and it has three advantages that I want to point out. You can see in the diagram I've labeled A. It's got a flat surface that it launches from. This is going to make it really easy to measure angle. You can use your phone to measure angle, and the Apple compass you can measure degrees, and an Android you can download an app to measure degrees, and it's accurate to within about a degree, so that will be adequate for our purposes. The other thing you'll notice, point B, it has a way to adjust the launch angle, and point C, you're only using something bending to store your potential energy in, so it's pretty straightforward to get the use elastic stored energy to launch your projectile. As far as your projectiles, you have freedom there to choose whatever you like. I've found that when you do these designs, if you work smaller, it's usually easier to solve problems, so like 12 to 18 inches tall. However, I am not going to put any size constraints on this. If you want to build larger or smaller, it's your design. You also get to choose a projectile. Don't use anything alive. We have to remain ethical in this. And design it to be durable. You have to launch it several times, like dozens of times. And you're going to collect a lot of data. So make sure you're designing with toughness in mind and building in such a way that you can that it can withstand a lot of use, or that it can easily be repaired. And again, I want to stress this. This has to be constructed using materials that you have on hand and tools you have on hand, because I don't want you to go out and get supplies. That's not my intent here. So use recycled materials, craft supplies, stuff out of the garage, stuff out of the trash can. Be creative. Let's talk about digital notebooks. Okay, I've had several students say, why do we have to use paper all the time? Why can't we use a digital notebook? So let's give this a whirl. I want you to use Google Slides. That's because it's easy to change your text and images using colors and shapes and that sort of thing. Also, you need to date your entries as you work. Be sure you start your writing with dates, and that way we have some chronology. Choose anything that you like. I do want it to emulate A4 paper, so choose File and Page Setup and Custom. Set the width to 8.3 inches and the height to 11.17 inches. It's just like the presentation the instructions are in. And then also choose Insert and Slide Numbers. That way every page will have a number on it at the bottom right, and that way we have numbered pages, and that way if you need to refer to different things, you can refer to page numbers. It's also helpful to know the keyboard shortcuts for making the fonts larger and smaller. This is something I use frequently to make the text fit into the spaces that I have, and also to make it easier to read and digest the information. Let's talk about the notebook content order. So I expect your submissions to be in this order. You're going to have a title page. You're going to include the design brief and a list of constraints. You're going to have your brainstorming ideas, your decision matrix, and your final design solution. I do want to point out this line here. Some of you are in the bad habit of just circling one of your crappy concept sketches. Step up your work here. I need you to do a really nice final design solution drawing. Okay, it should be like a full page. Could be done in 3D modeling if you want to take some time to do that. But don't just say, oh look, it's a triangle with a little crossbow on top and I'm going to circle this one, that's what I'm building. Okay, don't do that. Design modifications that you make along the way as you build, you need to list those out there. Your final design documentation, this is where you're going to have a picture of what you actually built, okay? And then your solution analysis, that's photographs of testing and calculations and data tables and charts and graphs. There's a section for solution analysis that will detail what goes in here. And then a summary of testing results, okay? And then the final will be the reflection, and this is how well did it solve the problem, and what did you learn, and how would you improve it. And let's look at the first Canvas submission. So when you get to the point that you have completed your final design solution, as is the drawings, submit these 3 sections: the brainstorming ideas, your decision matrix, and the final design solution. So you can use the print function and choose which slides you want and print just those and then send it to a PDF print. Okay, then turn that in on Canvas. Let's look at the solution analysis. Convert everything to meters. All of our measurements are going to be in meters. So if you have inches and feet to measure with, just use Google to convert everything. And you need to fire your solution 10 times minimum per launch angle, and you need to have a data table that has the trial number, so you're going to have the 1 through 10, the measured range, the launch angle, and the initial velocity. And I would also suggest trying different angles. So you're going to do 10 per angle. And there's your formula. I give you some information about how to calculate your initial velocity using Google Sheets here. One of the main problem is this. Google Sheets and any spreadsheet, they default to radians instead of degrees, so you have to convert degrees to radians at some point. And then the summary data, you're going to show me the range, mean, median, and standard deviation, and initial velocity, mean, median, and standard deviation for every angle that you launch with, and then answer these discussion questions and make some graphs for me. After you've done your initial testing, you should have a good idea of the way your launcher performs, and now you're going to do a precision test. So you're going to set up a cup to launch the projectile into. You determine the distance and set your angle, and you're going to tell me how often you make it into the cup, and if you miss it, how far you missed it by, and that's going to let you make some really nice graphs for me to show your performance when you try to hit a target. Before you submit your work, be sure you've got the correct format, that all the sections are completed, and that the presentation flows logically, and that it's easy to follow and the information is clearly presented. And when you're done with that, you'll submit it into Canvas, the entire notebook this time, in the assignment launch notebook. All right, if there's any questions, please reach out to me.